The other presenters.
Hi, I'm Jeff Applewhite. I'm a technical marketing engineer at NetApp and here to talk about Manila.
Hi, I'm Malini Bandaru from Intel, and I'm covering for Wei Tin Chen, and we hope you enjoy this session.
All right, great. So to go over what we're going to be talking about today very briefly, first we're going to talk about what Sahara and Manila respectively are, for those of us who don't know. Then we're going to be going into the state of Sahara data processing prior to Liberty and the state of it now. There's a lot more Manila. We're then going to talk about 3 different approaches to Manila integration, 2 of which are available to you today, and 1 of which is still a work in progress, but it's pretty exciting. Then we'll conclude and do a brief Q&A. Okay, so OpenStack Sahara is the OpenStack data processing service. The fundamental problem that we're trying to address is that big data clusters, whether it's Hadoop or Spark or Storm, it's not quite the Hadoop show anymore by any means, was a few years ago, are difficult to configure. They promise that you'll be able to use commodity hardware very inexpensively, but then when those nodes fail, they require expert maintenance to repair, which is reasonably expensive. The demand for data processing as a resource will naturally increase over time. If you lock yourself into a fixed size cluster, you're kind of going to be doomed eventually. And finally, if you do have one bare metal cluster, if it does go down, you can lose a lot of time, money, data, etc. So it's a lot harder to provision these clusters than it needs to be, and it hurts organizations. So our solution, of course, is to put all this in a cloud, allow you to use interfaces, to create clusters, to scale your clusters, and to run elastic data processing jobs, whether you like to use Pig, Hive, Java, MapReduce, Storm, Spark, whatever you like. We give you easy configuration options that just work, as well as very sophisticated in-depth configuration management for those who know how to use it and want to. And that's fundamentally what we do in OpenStack Sahara. We have 2 fundamental APIs, the Cluster Management API up top, and the Elastic Data Processing API down at the bottom. And the Manila integration that we're going to be talking about actually touches both of these at different points. We'll be talking about that in a bit. And our architecture is fundamentally very similar to most OpenStack services or as-a-service services. We have our service itself has a job manager, which, first we have a cluster configuration manager, which reaches through our vendor plugins, whether those are native, upstream, vanilla, Spark or Hadoop, Hortonworks, Cloudera, et cetera, reaches out to Heat, to provision resources to build your cluster. Then we use those vendor plugins to configure the cluster together, make it work. We also, in our elastic data processing, have data sources. And right now, we had Swift as a data source before. We, of course, have native HDFS within your cluster. And now we have Manila, which is really what we're here to talk about today. I'm going to turn it over to Jeff now for Manila and much prettier pictures that were made by marketers instead of developers.
Thanks, Ethan. So so Manila, for those of you who are not familiar with it, Manila is the file sharing service within OpenStack. It actually was initiated by NetApp, but we've invited a lot of our even competitors to come and contribute code to it. It now has a pretty broad user base and also contributors, many drivers that plug into it. So anything that's a file system can be exposed through Manila. So if you think about let's just take an example like a VDI deployment. We have virtual desktops, and those virtual desktops or virtual instances need to share file systems. So with Manila, you can actually do that. So in this example here, you can see the R&D department has a share, and the virtual machines number 1 and 7 are given access to that through Manila. And then the marketing department also has shares, and virtual machines 6 and 8 are given access through Manila. So it's a way to provision file systems in a cloud and then share those out to instances. And typically the access is based on IP address. And I'll show you in a little bit the APIs that are used to control that. As I said, there are a number of people are contributing. There's code in there now for HDFS drivers. NFS and CIFS are covered by the NetApp driver. GlusterFS is another option. So if you go out and look at the documentation for Manila, there's a lot of a lot of drivers out there. Another thing I did want to correct, the recent user survey showed about 8% uptake in the Manila project, 5% in production. So this is what we now consider to be a mature, stable, sort of enterprise 1.0, ready service. This is just sort of a high-level overview of the way you interact. It's very simple. For those of you who know Cinder, Manila is a very similar layout as far as the interaction. So the end users are interacting with the Manila API. Requests come in, they go in the message queue. If there's persistent data, for instance, about shares, or metadata that needs to go into the database, that's stored there, obviously. And then the Manila scheduler at the high level is responsible for knowing about all the back-end shares that are available to it and knowing what those share capacities are, and then making a provisioning successful down to the back ends. And so this is where your back end could be NFS, it could be HDFS, it could be a number of different file systems, ClusterFS, GPFS as well. And I just want to highlight a couple of the APIs here. These are that are most relevant to sort of a provisioning scenario within Manila and Sahara. The first one would be the Manila create operation. So, for example, I'll talk about the NetApp driver. So when you do a Manila create, basically what's happening is calls are made to create a flex vol on our NetApp controller, and then when you do an access allow, then we actually modify it's essentially kind of like an export FS command for those of you that know Unix, to get access to certain IP addresses. So those are the two sort of key APIs. Obviously, you can delete a share, edit a share, list and show a share, and then deny access as well. And then, so how does this tie together? This is actually sort of a high-level diagram of what you would see. In the top right corner, you see Sahara as the controller. Its responsibility is to actually spin up the Spark nodes in the big data cluster, so you can do your processing. And then once a share is created, you can create templates. And I actually have a technical report that I'll give you a link to at the end of the presentation here, where all this is in great detail. But basically, at a high level, you're creating a share. You're making the Sahara controller aware of it through a base template. And then when that template is spun up and these nodes get created that you see here, the worker nodes and the master nodes, they will come up fully enabled with a share that's automatically mounted, so that all of those nodes can share the NFS data that's accessed by all of them. So it's a great use case for where you want to pull files in or write files out. You can also do HDFS puts into the HDFS from those shared files. So, and this should make life easier a little for big data operators. Okay.
So what's the goal? We basically want Sahara and Manila to work together. So we want them to work together. We want our life to get easier. And let's see how we do this. Basically, we wanted to integrate with multiple different storage backends and protocols, and Sahara will make this possible with Manila. What do we have pre-Liberty? What do we have in Kilo? Basically, there are 3 patterns that we support as of Kilo. In the first one, you have both your compute, your processing of the data, and the HDFS file system in the same VM. That's the first pattern we indicate over there. In the second one, the data processing can happen in one VM, and the data itself, your Hadoop file system, could be in another VM or in a bare metal, whatever, an external Hadoop file system. In the third pattern, you basically access the data through Swift. So there is some, driver access direct through your Hadoop file system to Swift. You can process it, in a continuous fashion. What do we have in Liberty? Pattern 4 and 5. 6, we'll get to in a little bit with Jeff. What does pattern 4 do? It uses the Manila file service system. It has a Hadoop driver, an HDFS driver, and through your VM, you can access the Hadoop file system through Manila. In pattern 5, there's a little difference. You have a local volume, and that local volume can be backed by any data behind it. It could be an NFS driver, so access to NFS data in the backend. It could be cluster, and that's a very important contribution in Liberty. So when you use a local storage system, there are many benefits, and Ethan will cover that, and Jeff will go further on this. So I'm going to talk a little more about pattern 4 here. 5, go down. Okay, so Manila HDFS driver. How does it look? Think about a cluster in your cloud, multiple compute nodes, each of them may be hosting multiple virtual machines, and then they're all going to talk to your Manila file share system, which has the HDFS driver in it. That goes to a name node, it goes to different data nodes, all of that is accessible to your computes out there. So essentially you have an HDFS system that's external and you are accessing it, and the Hadoop file system, all that's good. It's out there. It's connected to your VMs out there, and the Manila basically helps you share that data. The advantage is you've accessed this external system and you've centralized management to your HDFS file system. There's some limitations today. One of them is the way we access. Normally in OpenStack, you have Keystone, and each user, each tenant has access to only their resources. So that part is not entirely translated into the HDFS file system through this driver. So it's a single, access point, single user. So that's a limitation today, and that can be something that we have to address in the coming releases. How do you set this all up? You basically have to change the Manila conf file. You have to ensure that your user login name, access, password, etc., all set correctly, and your service needs to use the HDFS user login system. You do your usual mount, you do your usual share, all that kind of stuff. Go right through your Manila system because all the driver capability exists. So once you've configured it, you need to restart your Manila service and you're good to go. Okay, so what did you get out of all this? You basically have the system set up, you have access to your data, and now it's an external HDFS data. And as I mentioned, you have a little bit of limitation from the user access point. I mean, there's more access than you really want, but it's a step in the right direction. And with that, I hand off to Jeff.
Okay, so now we're going to talk about what was pattern 5 from Malini's bit of the presentation, mounting NFS shares to your clusters within Sahara. And this is new work within the Sahara project, primarily by the Red Hat team, myself, Trevor McKay, Chad Roberts. And we support a few use cases here. The feature is that we can now mount Manila NFS shares. It is NFS right now. The mechanism we created is very extensible to new file systems as we go, cluster, etc. Right now, anything that expresses an NFS interface we can mount, and we'll be hopefully adding additional driver support in the future. But you can mount those shares to every node in a cluster, or you can specify node group types. So if you only want shares mounted to your name nodes, your data nodes, your masters, your slaves, etc., you can do that as well and have that level of specificity. The API, you can see to the right, very simple. When you're creating a cluster or a node group template, you create shares, you create a list that contains an ID of the share as registered in Manila. You can optionally provide a path at which to mount that share, and provide the access level at which you want your cluster to be able to access it, either read-write or read-only per Manila's API. This API actually is only required for users who aren't intending to use Sahara's EDP features, it should be noted. If you are using Sahara's EDP features, as we're about to go over, when you create a job binary or a data source in Sahara, Sahara will automatically mount the appropriate share for you, and you don't have to worry about it. So the first use case that we cover is binary data storage. This is the case in which you've created your Spark job or your Hadoop job, etc. You have a jar, you want to register it with Sahara so it can be run repeatably within your cluster. So these have a comparatively small size. These aren't really big data. So the initial location of these files is irrelevant to performance. Before Liberty in Sahara, you could store these in Swift, you could store these in the Sahara internal DB. That last solution was never really a great idea. It was pretty much there for very early on before users started adopting Swift and OpenStack very heavily. But now we have Manila NFS storage as well, which can really be a very great solution because you can do your version control directly on your native FS. It provides very reliable long-term storage if you're using transient clusters. Clusters on different networks can all route to that share without exposing them to each other. And also read-only access is really very appropriate for clusters in this case. There's no reason why a cluster should have write access to your binary repository. It should just consume that. So this is sort of what we're fundamentally doing. You have a Manila share expressing an NFS driver. In this case, that NFS driver is actually backed by a Gluster file system. Your Sahara cluster at the top is routing down through Manila to your NFS file system. We're mounting that, and it's pulling the data back into your HDFS. Now, you may say, OK, I'm losing data locality. That's true. Effectively, you're doing the equivalent of a Hadoop FS put from your NFS share in Manila back into your Sahara. Nonetheless, having standard FS access to data is really nice in the job binary case. In the data source case, you can lose a little bit of performance, but it's still convenient in many cases, especially small outputs. So fundamentally, this is the workflow for NFS binary storage and input data. You create a Manila NFS share, and just as Jeff was talking about, you then place your binary file or your data on the share at absolute path to binary.jar, wherever you like it. You can then create a Sahara job binary object with that path reference, and that's just prior we had internal DB or Swift : / Now we have Manila, share UID, and the path. You utilize that job binary in your job template just as you have in the past. You can then create a Sahara a data source using the precise same URL structure, pull it in, and it runs a job from the template using that data source and that binary. As I've noted, if you are using Sahara's EDP, you don't actually have to do anything new with the API at all to mount these shares, except for using that new URL form. Sahara will automatically check to make sure that that share is mounted to your cluster. If it's not, it'll mount it for you, and you're good to go. No additional work needed. In that case, it does use some defaults for permissions. It assumes you're going to need read-write, which you may not want, and it defaults to the path mount share UUID. This slide is here primarily for reference for people reading the presentation afterwards, but we'll go into it a little bit. I'm not going to deal with all of it by any means. But fundamentally, this is sort of how we make the sausage. When we check to make sure that the shares are mounted, we check to make sure first that you have the proper utilities to actually mount a share. If they're not there, we download them. However, we want to make sure that you can use your Sahara cluster in a non-network capacity. So if they are already there, you don't need network newly to reach out to download those utilities. We then call out to Manila to access allow for each IP, just as Jeff was talking about, and we mount. At that point, we just translate your paths from the Manila UUID back to a file system path, and you're good to go. There's slightly different implementations for Uzi, Spark, and Storm. You can look at those if you like. And I just want to shout out to the Manila team. As I'm saying this, doing that integration work was really very clean and painless. It's a nice API. Take a look at it if you haven't already. Seriously, it's kind of great. OK, so some screenshots. This is creating a share. Share name, share one, protocol, HDFS, et cetera, et cetera. For these screenshots, we're going to be looking at the external HDFS case that Malini talked about. And then you've got your share. Bunch of details on it. At this point, you create data source. That drop down with data source type, HDFS, Swift, NFS, sadly, the UI patches for this particular feature are not in the official Liberty release. They're coming very swiftly. The Horizon patches didn't quite land, so a lot of this is API only at this point. Not so great to screenshot as one might hope. Nonetheless, very usable and tested. And now I'm going to turn it back over to Jeff to talk about the NetApp NFS connector.
Thanks.
And where we're going from here.
Yeah, I'm going to switch to that in just a minute. One other use case, though, I would highlight with Manila. As an administrator, not only could you create a new share, you could actually manage an existing share. So one of our use cases was sort of an enterprise scenario where data might be sitting on an NFS server. You want to bring that in, make it available for processing, and then perhaps write data out to an NFS share where then you could share that to your enterprise users. So all that feature, as Ethan said, is now there in Liberty, and I'll give you a link to how you can actually do that with some command line and some GUI, as Ethan said. In Mitaka, the GUI patches will land for all of the integrations that I'm mentioning. So the command line support is there now today for Manila. So we've covered a number of use cases. So this is number 6. This is the last use case where instead of actually creating an NFS share and making that available through the cluster, now we're going to access data directly through what we call the Hadoop NFS connector. This is a proposal actually that was made by Wai-Ting Chen from Intel, and also appreciate Intel's support for the HDFS driver, as well as the future work that they're committed to for this to integrate our connector. So basically, at a high level, the way this connector works is it's a Java jar file that you tell your Hadoop cluster about, and with that, you can then reference NFS paths in your Hadoop job. So you can run a TerraSort, as I'll get into in a minute, using NFS file paths. So rather than where in the previous use case, in use case 5, there was a share available on all of your Hadoop nodes that you could then copy into HDFS. In this case, NFS is actually hiding behind HDFS, if that makes sense. So the connector actually talks to files that are sitting on HDFS, or sitting on NFS rather, and then exposes those up as HDFS. So the end user and the applications never know that there's actually NFS on the back end of this. So it's a great use case for development. You can't have big data jobs without developers. Many of you know that's the goal here is to make it easy for developers to access their data and get started. So if you've got data sets that are sitting out on NFS, the connector would be a great way to get started and expose those. So as I said, it's an NFS client. It's written in Java. It's completely open source. It's out there. I'll give you a link in a little bit where you can get to this. It implements the Hadoop file system API, as I said, and doesn't require any changes to the Hadoop framework or to user programs. And so in this use case, we would actually be eliminating copying data from NFS into HDFS. It would just live on NFS and actually be exposed as HDFS. And the plugin, a lot of the work was actually done to optimize performance for NFS. So there's a lot of prefetching for reads and a lot of optimizing of how writes get flushed out, because obviously HDFS is not a file system that was written with NFS in mind. So the connector does a lot of work to optimize the performance on a read and on the write side. It has different modes. So if you want to optimize it for reads, you can do that. If you want to optimize it for writes, you can also do that. And so this is the use case here. So at a high level, you're going to have virtual machines. They're going to be pre-configured. We're working on actually building a virtual machine base image that has the Hadoop NFS, the NetApp NFS connector built into it, similarly as you would have in Amazon. You have an AMI that has the big data tool sort of integrated into it. And so then those nodes would be able to come up and speak NFS directly. They would already know about that protocol at the HDFS level or within Hadoop. And then the Manila comes into this, where you could provision a share, or as I said, you could manage an existing share where data lives, and then the NFS connector would talk down to that share. And all this could be automated through APIs. And this is the proposal that Wai-Ting is working on. There's a reference down there to the blueprint for that. You can see it's a little bit small, but so really that kind of completes the picture as far as enabling NFS as a particular backend for big data workloads. There are a couple of choices with the NFS connector. You can deploy it in two different modes. So in the first mode, you're completely speaking NFS v3. The end user doesn't need to know anything about it, and it's just presented up as an HDFS file system. And that's simpler. It's all NFS on the back end. There's also a mode where it's HDFS and NFS. So you could have a case where, let's say within HDFS, you do an HDFS ls / and then there's a /NFS that resides within your HDFS file system that's back-ended by the connector, if that makes sense. So you can have it mixed where your HDFS data is both on your data nodes as local data and also can supplement with that with paths within HDFS. It's a bit confusing, but so one of the things to keep in mind, as I said, this is open source, so you can go out there on GitHub and get this connector, play around with it. There's good directions on how to configure that up. And this is really a benefit that I'd like to highlight. I mean, I'm a marketing engineer, so I get paid to talk about our value. And so with NetApp, at least, you have the benefit of, all the things you come to know about with NetApp, which snapshots, the ability to do flex clones, so you can make zero cost copies of your data. So in a development environment with big data where you have a large data set, but you want to make a small change to it, you can do flex clone of that, make a small change and not really incur any additional space penalty. Also with Manila, Snap Mirror is an option. You can filter on volumes that are mirrored to other locations for data recovery. And also in Mitaka, recovery groups, you can actually actually do full-blown disaster recovery in the Mitaka release, but not in Liberty. And this is an example I talked about where you can actually run a Hadoop command, and in this example, we're pointing it to an NFS path rather than a HDFS path, and that's what the plugin enables. It enables the cluster to understand the NFS semantics here, give it an NFS : / the host name or the IP address of the server where the NFS is, the port, which is 2049, and then the path to the file that you want to serve as your input. And then you can output it to /terra out, which in this case would be, this is a mixed mode example where /terra out is actually residing within HDFS. And similarly, you can do, the second command is just an example where both paths, the input and the output, are residing on NFS. And those are the references there for the connector at the bottom there off our netapp.com site, and also github.com where the excuse me, where the connector lives. So I want to summarize a bit. So thinking back to, really this all started, there was sort of a groundswell of, demand really within the Sahara community, and also a recognition that Manila could solve some of the problems that big data administrators were experiencing. Needed easier ways to get files in and out of their clusters, and Swift worked great in some cases, but in some cases it may not be the best solution. So we enabled that with what Ethan was describing. Intel enabled the Manila HDFS driver so that you can use Manila and the APIs to provision and manage HDFS. And this is the link I told you about. Actually, if you scan that QR code, it'll take you straight to the technical report that goes into the details of use case 5, right? Yeah. So the actual details of how you could either manage or create an NFS share, bring it in, automatically mount it on your Sahara cluster, and then access that data natively. That's there, the QR code and the TR4464. And then the last case is the one that I just discussed with the NFS connector for Hadoop. That'll give you the link to find that on github.com. And I'll open it up to other closing comments from you all. How are we doing on time here?
I think we're just about set for a good 10 minutes of questions or so, which is good.
Yeah.
I just wanted, as one closing comment, there are 3 companies up here. As one of the contributors to that joint effort, the 3 companies up here each really deserve to be up here in this effort, and seeing this sort of collaboration happen, across really one feature set during one cycle by three fairly major companies has been great to see and is a real testament to the spirit of OpenStack that we're all trying to embody here. So that's all.
Yep. And I'll also just point everybody to our documentation at github.io. This is our sort of one-stop shop at NetApp for any information around OpenStack. So if you want to find out about our the Manila the documentation, the deployment and operations guide is a great reference there. If you're new to deploying Manila and you're looking at that as a proof of concept, you can find that information there. Also, there's blogs as well. There's one about the new technical report that I mentioned. And
Do stop by our
oh
booth.
wait,
and
there's
get
more. Sorry.
Do stop by our booth and get your passport, clipped, and you could get a compute stick. So please stop by our booth.
I want one.
Yeah, you can have one. You can have one.
So questions? Does anybody have anything? Yes. I think we have Ben Swartzlander in the back too. If you have questions about that go beyond my knowledge of Manila, so.
Like we have good support for or the driver for HDFS, right? I think we have support for RDD in the Spark, right? Means any driver support for Manila or maybe in Sahara for the Spark API for RDD.
Sure. So Spark itself is effectively a plugin
Yep.
in Sahara, right? So we have the Hadoop plugins, and then we have our Spark plugin, and that binary is a little bit orthogonal with the data source, right?
Okay.
You can use Spark with any number of data sources, and you can use Hadoop with any number of data sources. So Spark we have routed so you can use the NFS or external HDFS data sources, just as we've done with Hadoop.
So
as well.
how take the data, real-time data, right? Like in the Spark, we have taking the real-time data for processing. So
Sure.
our system will take
Okay.
the real-time data because nowadays we want the real-time
Sure.
data to be processed, right? So
So in this case, with the NFS data, you'd give Spark a file system reference.
okay,
And if Spark is, if your application is constantly capable of reaching out to that Spark file system reference and pulling data in from it, then you could perfectly well use this NFS
but it supports.
driver as it is.
But it supports RDD.
I don't know that we've done a proper reference architecture and testing on RDD.
Okay.
So I don't want to definitively say that you can and that it's perfect,
Okay.
but it should be theoretically possible, based on my understanding. Yes.
And one more thing, like we have NFS support, right? Does we have NFS version 4.1 support also, like for SC Linux and Kerberos for the security point of view?
I'm gonna get that.
So the NFS, well, so with the connector that I spoke about in scenario 6, it's NFS v3 only. But
Okay.
with Manila, a share on all nodes, that would be any protocol that we want to support, that the back end would support, basically. Yeah. So yes, 4.1
Is
or PNFS.
is support, right?
Yes,
Okay.
as a share. But the connector is limited to v3. So in the case where you're accessing, HDFS is accessing files sitting on an NFS share through our connector, that's limited to v3. But Manila itself can provision through 3, 4, or 4.1.
Like you have seen that one dashboard, right? We have support from the dashboard. We can pull the resources. But if in my Hadoop cluster, if I host HDFS through Kerberos support, so does the API will support? Does we have some plugin to first go through the Kerberos and then?
I'm not an expert on the HDFS plugin, but my understanding it's based on basically fairly basic HDFS access through the HDFS user, and there's some limitations around security control with that driver. You want to add any color to that, Ethan?
Yeah.
Yeah.
I mean, you're touching on the point that reference architecture 4, which Malini talked about, does have effectively, HDFS file system and sort of Linux level permissions on it that you go into your share and create the appropriate folders and such. As such, and because some of those permissions need to be set in manila.conf, I don't know that solution is really certainly public cloud and multi-tenant ready. and that I'd only say that it's appropriate for security in a private cloud context. The NFS share mounting through Manila, while you lose some data locality, you can also use it in a multi-tenant public cloud context fine. You have keystone permissions on both sides of the equation.
And one last small question.
Sure. Okay.
We have our in the last diagram we have for data distributed processing we have yarn support, right, for repository manager, sorry, for resource manager, right? Does we have support for mesos also for resource manager in your Manila API? In the last diagram, in architect diagram, you have written like the yarn for resource manager, right? That's support in Sahara or Manila, right? So if I change yarn to mesos resource manager, does it suppose mesos also?
I think our connector has support for that. Is that what you're asking about, the connector?
Yeah, I'm asking about
Yes.
the connector. Yes.
Yeah, but that would be next cycle development work at least.
Okay.
So let's take other questions. Who is next? Him in the back? Okay. Then we'll get.
Are there plans to support locality, let's say, for example, for ClusterFS?
So the NFS connector is great for data locality. At this point, with the share mounting mechanism, if you mount a GlusterFS share and then create sort of put a GlusterFS driver into your Hadoop cluster so that it knows that it can talk to GlusterFS and use data locality that way. It's certainly feasible in the future. It's not currently implemented because we haven't specifically created a GFS share mounter. But there's nothing that I can see that forbids it, and thus it should be done.
Yeah, the locality aspect is the relevant part, I guess, the IP
Yes.
mapping of which machines to which host they run on and so on.
Yeah,
and so forth.
absolutely. And the work that Jeff's talking about for next cycle will also allow that, in native NFS and anything that it can express an NFS interface.
Yeah, and one thing I didn't mention is that the connector for Hadoop actually allows you to have multiple mounts. So you can actually have a large cluster of NFS servers, and you can have connections to multiple mounts on the back end. So you're not limited to a single mount by any stretch or any single piece of hardware. So if you want to scale up, have multiple nodes available to serve that NFS data up, that is an option through the connector.
Thank you.
Oh, microphone.
Thank you. My question is, which component take care of the replication? I mean, Hadoop itself, or the Manila, or the NetApp appliance? Which
I'm sorry, I didn't understand.
replication?
Oh, replication. Okay. So replication is something that's built in as a feature within Manila. You can create shares and enable replication basically in one operation. And also, as I said, disaster recovery. Ben, keep me honest here. Was that in Liberty or feature? Okay. Future. Okay. All right. So disaster recovery, DR, Manila DR is, I guess, future release, perhaps Mataka.
But if you have any external HDFS that's provisioned by Manila, then that Manila machine set will take care of replication. If you provision any HDFS within Sahara, then that VM set provisioned by Sahara will take care of replication. Wherever your name node is, from there your replication will flow.
Yep. Was there another question?
Yeah, I have a question. So you just mentioned we have three options. One is HDFS, the other is a general NFS share, the other one is a NetApp connector file system. So I'm not sure any plan will support the general NFS share, or we still need to do more things in the Sahara to support this one.
A general share? So yeah, the NFS connector will work with any NFS v3 compliant NFS server. It doesn't have to be a NetApp. We obviously like it if it's a NetApp, but it could be anything. And does that answer your question? But then as far as the shares, it's down to the Manila drivers that plug into Manila. And as I said, there's many drivers out there. So it's really down to the vendor implementation. I can speak, specifically about ours, but it really does come down to the driver.
Any other last questions? I think we're beginning to run out of time, but a little bit left.
Just along the lines of replication, have you made any sort of account for sort of the amplification situation? If you've got HDFS replicating and then the backend file system replicating, does the Manila stuff try to address that in any way?
Sure. So if you're using scenario 5, right, NFS is going to be replicating its data, and then you're effectively sort of pulling it into your local HDFS on your Hadoop cluster that's provisioned by Sahara. And that will perform replication for the length of the job on any intermediate data sets and then export it. At which point you can certainly go ahead and delete it if you're done with it. On the NFS side.
Yes, I mean, so as I said, it would be a driver-specific implementation. With the NetApp driver, if you enable replication, you're going to get, we're going to use our snap mirror technology to create a remote flex vol that's going to mirror. So with NetApp, at least, it's a flex vol that gets created and mirrored to a target. So any changes can be dynamically updated to that target based on how you set it up. So.
But there's no current configuration that would have sort of a multiplicative replication, right? Which is good.
Yeah, HDFS replication that'd be outside of Manila completely. Yeah.
But even though the flex wall is being replicated, what about the mount points? Like, let's say I lose it.
That's a good question. Yes. No, it would not. Yeah, you would not. Well, in a case where you create a Manila share that is replicated and you need that read-only, potentially you could mount that the target path as well. I have to think about that.
It would be a manual mount.
Yeah, you could mount out the mirrored target as well as a read-only. It cannot be changed, obviously, because it's a mirrored copy of the base. But perhaps for scaling up, that might be an option.
I'm sorry, I didn't quite get that. Is there a question?
Another one? Well, thank you for coming, and it's been great. And have a great conference.
Thank you.